All right, so here's the practice test for you guys. I'll try to go as good as I can. I'll show you at least one of them, and then I'll plug in the other one. I'll just give you the answers for the other ones. So on the first one here, again, kind of look at what they're asking you to do, and kind of look at, on this one here, look at the answers, all right? Because they're going to drag and drop all of these. And notice on here, the reflection in the x-axis one is down here. Hopefully that won't happen to you on the test tomorrow. But so I'm going to look at this one here, and again, choose one of them. So I'm looking at this A, B, C, D. All right. Now, if I'm going to look at the sides, it looks like the QPMN one. That's a 3/4. I don't think you guys are going to like that one. So try the WXYZ one first. So again, I think one of the things is to choose a point and see what happens. All right. On this one here, if we look, we can go 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, so that's 9 units left. And again, that's just one from that one point. And then let's see if I go down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this would be 12 down. So let's look and see if we have those choices. So, yep, 9 units and 12 down. So we're going to put quadrilateral A, B, C, D. And then we're going to put quadrilateral, because remember, you're dragging and dropping these. W, X, Y, Z. And what did I just tell you? We went 9 units left. And 12 units down. All right, so kind of look at that as you're doing it. Look at what they gave you, all right? So let's see. Those are the 3 that I can cross out. All right, let's look at the next one. Now, I have 3 triangles left. And it looks like to me, it looks like EFG and HJK, they look about the same. So let's go ahead and look at this one right here. Okay, I'm only choosing this one because if I do the E, it comes out about the same. So on that one there, it's going to be 5 and 2. All right. What's the one that corresponds to it? Now, I kind of want to think. Remember, I told you to look at rotation, reflection, translation, and dilation. Well, it's not getting bigger or smaller, so we know it's not a dilation. So again, if I look at that one there, that's going to correspond to this J here. And that J there is at what? -5 and -2. And so remember, what that gave you is a rotation. Remember, a rotation at 180 degrees tells us that we have an AB. And with that, it's going to map to -B, -A, which is exactly what that one did. All right. So since that's what that one did, we're going to say triangle, and I started with EFG. And figure 2 is triangle HJK. And we just said a rotation of 180 degrees about the origin. And I'm not going to write all that down for you. So there we go. Number 1 done. Okay. On number 2 here, remember a vector shows the direction that it's going to go. So on this one here, when I look at it, and we know we're going to take a point and we're going to move it -1 in the x direction, and we're going to move it y, and then y direction. 7 in the y direction. I'm sorry. So it looks like we have to graph it, right? Yeah. So again, I'm going to move each one, and again, they didn't name the points, so they're calling them A, B, C, but if you notice, they didn't put it here. So when we graph it, we obviously don't have to put A, B, and C on there. So I'm just going to take one of my points, this one here, I'm going to move it over 1, and then I'm going to go up 7. All right, so that would be one of my points. Again, I'm going to take this one, I'm going to go over 1, I'm going to go up 7. That one's going to go there, and then I'm going to go move over 1. I'm going to go up 7. All right, and let's see, I'll go ahead and change the color there, and then just draw your diagram. All right, so when you put those points together, again, I haven't seen what it does because I can't see the student version, but when I look at my answer key, it kind of shows that they're dashed, so I don't know if it dashes it for you. Okay. All right, let's see. Quadrilateral MNPQ has vertices M of 0 and 6, N form 4, P 6 and -1, and Q 2 and 0. Determine the coordinates of the vertices of the image of the quadrilateral after the translation. XY goes to or maps to x plus 2, y minus 1. So on this one here, every single one of them, you're going to do the same thing. You're going to plug in. So plug in. So on my M, here's my x and here's my y. So we know that x and y will map to, for M prime, it'll go 0 plus 2, and it'll go 6 minus 1. So we know that ends up being M prime is at 2 and 5. All right, so now you're going to plug in 2 and 5. And you're going to do the same thing for every other one, okay? You're going to do the same for n. So 4 plus 2, 4 minus 1, etc., etc. If you do that, then you should get, for n prime, 6 and 3. For p prime, you should get 8 and -2. And for q prime, you should get 4 and -1. Okay, so you should be able to do those. Okay, number 4. Excuse me. The coordinates of the vertices of quadrilateral ABCD are 2 and 3, 6 and -2. C is equal to 10 and -1, and for D, our points are 11 and 6. Identify the coordinates of the vertices after the composition. So remember, there's 2 of them, so we're going to do this thing twice. We're going to do the first one here, and then we're going to do the second one here. So notice when they have the answer here, they want the second one. They have the double prime here. All right, so remember that. So on the first one here, and again, I'm just going to do one of them for you. I'm going to call it A prime for you. And remember, for A prime, you're going to take A. So here's your X and Y. And you are going to take, and you're going to do 2 plus 8. And you're going to do 3 minus 4. So your A prime is going to be 10 and -1. Okay? But that's not the one they want. They want A double prime. So A double prime means we're going to take our X and our Y from our A prime, and we're going to plug those in. So on that one there, I'm going to get 10 minus 1. And I'm going to take, sorry, I didn't mean to close the parenthesis there. And then I'm going to take negative 1 plus 1. So for that one there, my a double prime, which will be the one that is my answer, will be at 9 and 0. So again, you would drag and drop that one here. So this one here will be 9 and 0. You'll do the same thing for all the other points. And you do that, you'll have 13 and negative 5. You'll have 17 and negative 4. And you'll have 18 and 3. And that's 17. All right, pretty straightforward right now, I would hope. All right, so let's see here. Determine the coordinates of the vertices of the image ABC after a reflection in the line y is equal to negative x. So remember, again, on this, you should be able to look at your textbook and look at what happens at a reflection. So that would be section 4.2 that we talked about reflections. And when it's in the line y is equal to negative x, our rule was we went from A, B, and again, since it's in the line y is equal to negative x, you're going to flip them and negate them. So it's going to go negative b, negative a. So if we do that for a prime, we're going to take and flip a and b. So here's your a, here's your b. So we're going to flip them and we're going to negate them. So that'll give us negative 4, negative 3. All right. So in this one here, my answer would be negative 4, negative 3. For my next one, it's negative 2, negative 3. And for C prime, it's going to be negative 2. And remember, a negative and a negative is a positive. So we'll have a positive 1 there. Okay. Number 6. Let's see here. They want us to graph both of them. So we're going to graph. Let's see here. What I'm going to go ahead and do A. So we're going to graph it, and we're going to go graph triangle ABC with vertices at 6 and 5, 9 and 7, and C at 8 and 1, and its image after a 90-degree rotation about the origin. All right, so let's go ahead, 6 and 5. And remember, they're going to be pretty particular here. If you don't, you have to make sure you have them right. So that's our A. It's not going to let you put the A there, though, or what it is. But that one's 6 and 5. And B will have, let's see, what is B? 9 and 7. So I'm going to go over 9 and up 7. So there's B at 9 and 7. And then C is at 8 and 1. So I'm going to go over 8 and up 1. And there's your C. Again, I'm sure it's not going to let you put that there, but again, it will want you to connect the dots. If you don't, it will probably mark you wrong. And your rotation. So a rotation for 90 degrees again, our rule is A and B maps to. Again, you're going to take and flip them. You're going to have B and negative A. Okay, so on this one here, when we had A, and our A was at 6 and 5, we are going to make it be A prime, and that will be negative 5 and 6. For B, we had 9 and 7, so we'll map it to B prime, which will give us negative 7 and positive 9. And then for C, we had 8 N1. And that'll map to C prime at -1 and 8. So we'll graph those ones. All right. So I just told you -5. So go over -5. I'm going to go up 6. -7 and up 9. And for C, we're going to go -1, and we're going to go up 8. So that would be our C prime. This will be our A prime, and this here will be our B prime. Again, they're not going to let you do that part, but again, you're going to have to connect the dots or they will not count it right. All right, pretty straightforward, ladies and gentlemen. Okay, number 7. Let's see. The distance between line A and B is 12 millimeters. The preimage is reflected in line B and then in line A. Describe a single transformation that maps the blue figure to the green figure. So remember, these lines are parallel. Okay. So this is the one we're starting with. So it's going to be a translation. All right. And this translation, again, we're saying it's moving this way. So we know it reflected and it's reflected, right? So this one maps to this one here. And remember, that means that we went, what direction did we go? We went left. And remember, if this here is 12 millimeters, right, what you have to do is just double this. Right? So what did I just tell you? The single transformation is a translation. And we went 24 millimeters. And we went left. Okay. Find the scale factor of the dilation. Then tell whether the dilation is a reduction or an enlargement. So remember, K is going to be equal to the image over the preimage. All right. The easiest way to remember it is the preimage is the prime one. The image is the prime one. Sorry, my bad. And then the preimage is what we started with. So if we look at that, we're going to get 10 over 20. And if I do that, I'm going to get 1/2. So our K is equal to 1/2. I'm not sure what happens, ladies and gentlemen. Remember that the program's pretty particular. So if you put 0.5, I'm not sure if it's going to give you the right answer. So, it's a fraction. Keep it as a fraction. Of course, I'll look at it just to make sure. And I'll look at some of you who already turned in your test. That'll maybe give me a chance to give you some hints on it tomorrow. So remember, if K is between 0 and 1, or it's a small fraction, remember 5/4 isn't between 0 and 1, but we know if it's between 0 and 1, we know it has to be a reduction. So the dilation is a reduction. And on that one, it looks like you're going to drop down and either choose enlargement or reduction. Okay. All right. So this next one here again, it looks like we're just doing a kind of word problem again here. So quadrilateral WXYZ has vertices -4 and 8. X is -4 and 0. Y is at the point -12 and 4. And Z is at the point 8, -8 and 16. Identify the coordinates of the vertices after each similarity transformation. So I'm going to do the same thing here like I did with the last one. I'll go ahead and do the first one, and then I'll write in the second ones. All right. So now on this one here, it looks like you're going to drag and drop the whole thing. So on the first one here, I have a W. Again, I'll call this my X and this here my Y. And on that one there, I'm going to take, and to get W prime, I'm going to take my -4 plus 4, and I'm going to take my 8 minus 4, because that's my translation. All right. And that means that I'm going to have W prime as 0 and 4. All right. I chose W prime because that's the first one they have. It looks like I have to drag and drop all of them in here. So I'm going to have 0 and 4. And then my other ones are going to be, for X prime, I'll get -8 and 0. I'll get 0 and -4. And I'll get -4 and 12. For the second one, remember, this here is now my new X and my new Y. So for Y double prime, W double prime, that was a tongue twister. I'm going to take 1/4 of a 0, and I'm going to take 1/4 of 4. Well, 1/4 of 0 is 0, and 1/4 of 4 is 1. All right, so same thing. I did the W prime. You can figure out the other ones for you. Just plug them in just like I did there. So I'll have 0 and 1. For X double prime, it's going to be -2 and 0. For Y double prime, I'm going to get 0 and -1. And for Z double prime, I'm going to get -1 and 3. Make sure you put them in the right order, ladies and gentlemen, because if you mix one of them, I know it's going to mark you wrong. Okay. Number 10. So it says, describe a similarity transformation that maps. Now remember, it's a transformation similarity, so that means that we're going to have two things happening to it. So the key to remember is, which one are they talking about? So we're talking about A, B, C, D, and we're going to, when we're done, we're going to put that at W, X, Y, and Z. So again, look for rotations, reflections, translations, all right? And then on this one here, it looks like it's going to get bigger or smaller, so we know that we're going to have a dilation. So again, what you can always do is you can always choose a point, ladies and gentlemen, if you want, but or you can think, am I rotating it? So it looks like this one right here, all right? It looks like I'm going to be rotating it here, because this point right here will correspond to this one, and D will correspond to Z. So I'm doing a rotation. Again, how long am I doing it? I'm doing it 1, and I'm in another quadrant. So that means I'm going to go 180. Again, you can always check by using the formula that I just showed you earlier, right? And again, which one was it? You should be able to tell me. So I'll tell you on this one right here, so I don't spend a lot of time. The first thing is 180 degrees rotation. And then remember, I told you to look at a dilation. So on this one here, we had 1. On this one here, it went to 2. If you wanted to check another one here, this one here was at 2. It went to 4. So we have a dilation. And it is centered at 0, 0. And since it got bigger, right, it got bigger. We went from 1 to 2. We went from 2 to 4. So it should be a scale factor of 2. And it looks like you'll drag those down and put the answer there. All right. I didn't know somebody almost got 100% on their practice test, except they said a scale factor of 1/2. All right. So remember, is it getting larger or is it getting smaller? Number 11. Okay. On this one here, find the angle of rotation that maps A to A double prime. So on this one here, we have 2 intersecting lines. Remember, if I have 2 intersecting lines, they're intersecting at a point, P. When they're intersecting at a line, remember the angle of rotation will be double the one that's there. All right? So if we're given that one, we know it's going to be 2 times 45 degrees. So our angle of rotation will be 90 degrees. Number 12, find the scale factor of the dilation, then tell whether the dilation is a reduction or an enlargement. So remember on this one here, again, the scale factor, the formula was K is equal to the image over the pre-image, or in this case, if you can just remember it, if they're going to give you P, you can always say it's P over P, P prime over P, which is equal to 18 force, which is equal to, again, it won't accept if you put 18 force. I'm sure it will mark it wrong because you know you can reduce that at fraction. So you should be able to say 9/2. All right. And again, I'm going to kind of check because I've noticed some people have some missing. So on this one here, it's going to be 4.5 or 9/2. All right. And again, I'll check and I'll let you know for sure if I can see based on what people have given me. And again, remember, in this case, K is greater than 1. So it's going to be an enlargement. So 13 says graph DEF with vertices D is at 1 and 1, E is at 3 and -1, and F is at 1 and -3, and its image after the dilation centered at the origin with a scale factor of 4. So remember, scale factor of 4, that means it's going to get larger. Remember, if it's a fraction, it'll get smaller. But again, just go ahead and take each one. So D is at 1 and 1. E is at 3 and -1, so 3 and -1. And F is at 1 and -3. So there's D, E, and F. Again, you're going to have to connect them. All right. And again, if you're not sure, ladies and gentlemen, just again, do what it asked you to do. So we know that our new D prime will be, it's at a scale factor of 4. So that means it's going to be 4 times our X, which was 1. and it's going to be 4 times our y, which was 1. So we know that d prime is going to be 4 and 4. All right. Similarly, e, again, we're going to have 4 times 3. And we're going to have 4 times negative 1. And again, that means our e prime will be at 12 and negative 4. And our f prime, again, we're going to have 4 times 1, comma, 4 times negative 3. That means our f prime is now going to be at 4 and negative 12. All right, so let's see what I just tell you, 4 and 4. So 4 and 4. So over 4, up 4. I told you 12 and negative 4, so I'm going to go to 12 and down 4. And then our last one I told you was at 4 and 12. 4 and negative 12, so over 4 and down negative 12. And again, connect your dots. All right. Sorry, that one's a little too far. I'm sure once you connect them, it's going to stop it. And again, that was, I'm sure you don't put these here. There's D prime, E prime, and F prime. Okay. The next one, the graph shows A, B, C, D with vertices at A is equal to negative 8 and 0, B is at negative 4 and 8, C is equal to 0 and negative 4, and D is negative 8 and negative 8. Graph the image of the quadrilateral after a dilation centered at the origin with a scale factor of negative 1/4. So remember, the 1/4 means it's going to get smaller, and the negative means you're going to have a rotation. But again, ladies and gentlemen, that shouldn't matter. You should just plug in your points. So again, A prime will be negative 1/4 times a negative 8. And our y value will be 1/4 times 0. And remember, 1/4 of 8, well, negative times a negative is a positive. 1/4 of 8 is the same as 8 divided by 4. So our A prime should be at 2 and 0. All right. I'll just tell you what the other ones will be. At B prime will be at 1 and negative 2. C prime will be at 0 and 1. And D prime will be at 2 and 2. So again, we're going to do all of those. So I just said A prime is at 2 and 0. I told you B prime is at 1 and negative 2. C, I just told you, was at 0 and 1. C prime, excuse me. And D prime was at 2 and 2. And again, connect those dots, in the right order. And there you go. And finally, the last one, it's still pretty simple. Okay. It's just slightly different. So you are using a magnifying glass that shows the image of the object that is 6 times the object's actual size. Determine the length of the image of the termite seen through the magnifying glass. So since it told us the image, all right, just remember your scale factor is equal to the image over the pre-image. All right. So in this case, let's just see what we know. We know that the figure is 6 times, so we know that our k, our scale factor, is equal to 6. Okay, we're finding the image. It says determine the length of the image. All right, and I'm just going to call it x. And then we know that the length of it, of that weird looking bug, is, well, it's a termite, is equal to 9.5. All right, so now there, just a proportion, stuff that we've learned before. If you want to put that 6 as a fraction, it's 6 over 1. And then remember, I can take x times 1, and I can take 6 times 9.5. X times 1 is just x. So x is equal to 6 times 9.5. I worked that out, ladies and gentlemen. 6 times 9.5 is 57 millimeters. So that's your answer there. Remember, the test will be very similar. Again, I've suggested many times, watch the video, stop it, do the problem. Hopefully you'll listen sometime. Good luck tomorrow.